Now I want to talk about effect size in ANOVAs. So remember, effect size is the same thing as saying the size of your treatment effect. In other words, how much influence does your independent variable have on your dependent variable? And we looked at effect size in chapter 7, and we talked about increasing effect size by increasing n, your sample size. We talked about running cleaner experiments, not making errors or falling asleep. And we also talked about strong manipulations. The stronger your manipulation, typically the greater your effect size. We also looked at how to measure effect size in t-tests. And to do that, you needed to calculate Cohen's d. And unfortunately, SPSS doesn't do it for you. Now, there is a new version of SPSS out, probably the one you're using, which is, I think, version 27. I'm using version 26, but I looked up the differences between the two, and it didn't say, oh, we finally decided to calculate Cohen's d for you. So you have to Google it. All right, this is not the case, however, for ANOVAs. When you run an ANOVA on SPSS, it will give you a measure of effect size called partial eta squared. And the symbol for it is here. By the way, if you need to retrieve that symbol, you can just go to my website, and there is a link for writing results in APA format. It's on the lab page. I can't remember exactly which page on the lab page, but it's there. And it's a Word document, and you just have to go to the ANOVA section, and you will see this symbol. Okay? All right, so what does partial eta squared do? Well, it looks at the variability associated with the effect. In other words, it's looking at how much of the variability in the scores, all right, was associated with the independent variable itself. And then it's dividing by the variability associated with the effect, so the same thing as here, but also combined with the variability associated with error. All right, so you're looking at how much of the total variability in the dependent variable is explained or accounted for by your independent variable. Partial eta squared can range from 0 to 1. It can't be negative. Why? Squared, right? Can you ever get a negative number if you square it? No. So it can range from 0 to 1, and 1 is the greatest effect size possible. Now this is different from Cohen's d, because Cohen's d, remember, can be negative and it doesn't stop at 1. You can get effect sizes greater than that. We don't tend to get that high in most experiments or studies in behavioral sciences, but it's possible. So just know that partial eta squared, then the highest you can go is 1, and it cannot be negative. So again, partial eta squared is telling you how much of the total variability in the DV, so all those scores in your DV, how much of that variability is explained or accounted for by the factor you tested. All right, so if it was, the inner voice, if that was the factor, then it's saying how much of the variability in self-esteem scores is explained by which inner voice you heard, if any. As far as guidelines for small, medium, and large effect size, just like Cohen's d, it depends on the field of investigation. What is small, medium, and large for us is going to be different than what it would be considered small, medium, and large for a physicist. All right, so just as a very rough guideline, 0.01 would be small, 0.06 is medium, 0.14 is large. Now that's more for us. That would not be for like chemists and physicists and people, working in sciences where a lot more of the variables can be controlled. We're so out of control in the behavioral sciences. Getting effect sizes this big, even though this is saying that our independent variable only explains 14% of all the variability in our scores, we would consider this to be quite good, quite large.